Hey there, it's Shannon Matchick-Myers, and here's just a short example of how to find the equation of the plane that passes through the point 2, 0, 1 and contains the line given by x over 2 equals y minus 4 over negative 1, which is equal to z. So the first thing that we want to do is find the direction numbers, right? So we'll find the direction numbers. And to do that, you basically need to set each equation equal to t and then isolate x, y, and z after that. So here we go. X over 2 equals t gives us x is equal to 2t, which means that a is equal to 2. That's our first direction number. And then y minus 4 over negative 1 equal to t gives us, with a little bit of algebra, what will we get? Y would equal to 4 minus t, which gives us that our second direction number is negative 1. And then z equals t, so that one's easy. That means c is 1. Cool so far? So a, b, and c are the direction numbers. So let's call it u equals abc, which equals 2, negative 1, 1. Cool so far? All right, so now we also need to find a point on the line so that we can make a vector out of this point and that given point. Let's call it the given point Q. All right, so we want to find a point on the line. Well, the easiest thing to do would be to let t equals 0. We'll let t equal to 0, and then plugging it into the original, or to what we found, we would get x is equal to 2 times 0, which is 0. Y would equal to 4 minus 0, which is 4. And then z would equal to 0, because z was equal to t. So a point on the line, call it P, is going to be 0, 4, 0. Now we need to form the vector that goes through these 2 points. So let's find PQ. PQ will equal to the vector. So Q, remember, was 2, 0, 1. So we'll have 2 minus 0, comma, 0 minus 4, comma, and 1 minus 0. So that directed segment, PQ, will be to negative 4, 1. And then the fourth step will be to find the vector normal to the plane. So basically that is merely our cross product of PQ and U. And so that will be the determinant I, J, and K. And then we've got PQ on the next line. So that was 2, negative 4, 1. And then our u vector we found with the direction numbers is 2, -1, 1. Good so far? All right, so then what we'll have, I'll expand about I, j, and k. So we'll have I times the determinant, -4, 1, -1, 1, going across, minus j times the determinant, 2, 1, 2, 1, plus k times the determinant, 2, -4, 2, -1, which will give us -4 minus -1 will be -3i, and then the j will zero out, and then we'll have -2 minus -8 would be plus 6 times k. And remember, this is the vector normal to the plane. So all we need to do is take that general equation, remember, so this is our fifth step. We're going to use this standard form, so a times, and this is the standard form for a plane, x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0. So the first step, we found the direction numbers for the line, right? So the direction numbers for the plane are going to be what we found with this vector normal. So we'd have -3 0 and 6. So if you want, we could call this, A1, B, A1, B1, C1, since we already used A, B, and C. And so we would end up having -3 times x minus, now remember our x1, y1, z1 are going to be the original, from the original Q that was given, 2, 0, 1. So we'd have x minus 2, and then we have 0 times, well, we can plug it in just for continuity's sakes, 0 times y minus 0, and then plus 6 times z minus, what was it again? Can't remember today, 1. And that's equal to 0. And so -3x plus 6 plus 6z minus 6 is equal to 0. And so you can either write it as -3x plus 6z is 0, or multiplying everything by -1, 3x minus 6z is 0. And you're all done. So I hope you have a wonderful morning, afternoon, or evening whenever you're watching the show. And hey, if you like what I'm doing, please subscribe and tell your friends. Bye.